Yo, yo, peace, cousins. All right, we're gonna start out your Gregorian 2014 miscalculation of time. Happy miscalculation of time, but we all love time with our families. That's all good. But this is your cousin Papote. We're gonna start it off a little deeper this year because you know how you guys make me so happy that you're so proud to be Boricua, and then we start getting into these conversations about migration and human origins and celestial space time. And I mean, to free Puerto Rico, you got to go through the whole gambit of knowledge from the first fucking apple chewing motherfucker all the way down to fucking nanotechnology before you could get into even the question of should you be goddamn free, dumbass. But here, we're going to break down a conversation that Kike started, alright? Alright, then he started it off with the expanding Earth, right? And I just wanted to, put my 2 cents into how I view space or time and stuff like that, alright? Now, this is like one of those pedestals that you put like a book on or something, and when I raise it forward like that, just so you can see it, it'll be imbalanced. It'll fall forward. So I gotta just keep my hands on this. So if you guys can just be patient with me, I'll do that. But to draw, I have to draw on it flat. So now, here it goes. Yo, peace, cousins. All right. So now, according to conventional science, the universe is 15 billion years old. Alright, and the Earth, okay, is 5 billion years old. Y'all got that? Universe 15 billion, Earth 5 billion. That's how many years old it is. Alright, so now, according to conventional science, there was a Big Bang, okay? A Big Bang. Alright? And we're not talking about the Big Bangs that was in Hunts Point. Talk about Big Bang Theory. Alright, Boricuas? Especially you brainiac motherfuckers that like to, So here you go. So what they're saying is that there was a fucking, a little point in the universe, right? That was that little freaking dot that all matter was that small, right? And then there was an explosion. And that explosion, I'm going to theoretically put a circle so it could qualify as a ring of pressure, or, a shock wave, or like a wave, okay? So that was the center of the universe. And this, for argument's sake, will be like the edge of the universe at 5 billion years. Alright, 5B. Okay? And then somewhere out here, it gotta be way bigger though. There'll be like another big circle. We'll draw it out for you fucking brainiacs. Alright? It ain't exactly a sphere, but I could have got a compass, but you get what I'm talking about. So now right here, on this edge, we're gonna call that 15B. Alright? Because that's today. Okay, so the little circle is when the creation of the Earth, 5 billion, and the 15 billion is the creation of, is the edge of the universe, because it's 15 billion years old. You see, when you have an explosion, alright, so that's for your military motherfuckers know what's up. When you have an explosion, depending on the container, is depending on the weak spot will fracture. So if you got a ball and you got the seam of the ball, which is where they will glue together, or you have a thin part of the ball, that thinnest part is where your energy will blow up. So when you look at a bomb blow up, the weakest point will blow out like a bubble, like an edge. Okay? So now, if you was underwater, factors that would need to be included on where the expansion of that explosion will go will be on the resistance that the water creates. So if you had like a grenade, is the resistance of the shell. But if you have, like, if you were in water and you had an explosion, a spontaneous explosion without a capsule or something that's, you know, the explosion is going to be contained within, then we just got to factor in the resistance that the water gives it, like the shock wave and the resistance of the water. But if we in space, there's no resistance because space is a vacuum, right? So according to the vacuum of space from the explosion, 5 billion years later, this is how big the universe was. The Earth could have been in here somewhere, who knows? And then 15 billion years later is today. Okay? And this is for people that like to measure, because this is a simple measurement. Like, you know what I mean? So what they're basically telling you, if they say that the Earth is 15 billion years old, is that from the point of this explosion, and you count Earth years, okay? So that's Earth years, 15 billion years later, it'll be that circle. So then from here to there is 15 billion light years. Right? If the universe is expanding at the speed of light, then from here to there it would be 15 billion years, and then you'd be traveling at the speed of light. So that's a light year, like, you know. So it'll take you 15 billion years to get from this point to this point. Okay? So now, it'll take you 15 billion years to travel from this point to this point. So you could recalculate that into light years. That's what I'm talking about. Okay? So it's 15 billion from here to here. Right? Which means that the actual size of the universe, okay, will be that same distance in light years twice. Because you got from there to there and there to there. So for argument's sake, I know you could travel 143,000 miles per second. Alright? But without doing that mathematics, let's suppose for argument's sake, from here to here was 15 billion light years. Because the math ain't going to change. It's going to be twice. So 15 billion light years and 15 billion light years from there will mean that from there to there is 30 billion light years. Alright? But only 15 billion years of time has gone by. So that means, okay, you can never possibly see the light from this side of the universe. And maybe that's why it appears flat. Because you could only see the one side of it. There's only 15 billion light years worth of time that has gone by from here to there. But the size of what's been occurring will be twice the amount of time. Because from there to there is 30 billion light years. And 30 billion light years don't exist in real time. Only 15 billion. So the amount of space from there to there translated in travel time could never be acquired because not enough time has possibly gone by. You getting it? And you ain't got enough. By the time you get from this side to this side, it'll be 45 billion or some shit like that. 45 billion years from now. Because the 15 billion that went by, the 15 billion that'll take you to go to there, and the 15 billion that'll go to there, and we're not even accounting for the rate of expansion because it'll be like 15 billion 230 years and or whatever the hell you gotta add. You gotta add at the rate of the expansion. In this case, we're saying that the rate of expansion is light years. Okay. Another thing to note, because I'm going to make this a short video, it's going to end in a few seconds. Another thing to take into consideration, okay, matter of fact, I'll just leave it right there. I'll leave it right there. That there's not enough time that has gone by for us to visibly observe the universe because the universe is twice as big as the amount of time that has passed by because it's space-time. Space. The amount of space within that time. That's Boricuas talking about physics. All right? This is your cousin Papote. Check it out. All right? Break it down with me. Peace.